John Derito, please confirm that you are able to hear me. I'm still working on the video. Confirm that you're able to hear the audio.
Yes, I can hear the audio.
Okay. What about you, Stacy? Are you able to hear me? Stacy Kimathi. Stacy, are you able to hear me? I'm working on the video. I'm using a different machine. My laptop, the hard disk began to have issues, so I'm having to replace the hard disk. So currently I'm using a different machine, so I'm trying to work on the camera so that we can start. You can tell the others to join us even as I do that. All right. John, you able to hear me?
Yes, I can hear you and see you at the same time.
Okay, and I hope you're not receiving any echo.
Yeah, I can receive some echoes.
What about now?
Still some echoes. I can't hear you. I can't hear you.
What about now?
Yes, though there are still some echoes, but I can hear you clearly, so maybe
Okay.
not sure the problem.
I'm trying to multi use the phone's camera together with the computer, because as I've said, I'm using a desktop here. My machine gave me some issues during the weekend, so I'm not able to use my machine for now. So that's why I'm trying to sync the phone with the computer so that I'll be able to do the meeting. But I'm trying to see how to solve the echo. Or do you have any suggestions on how I can solve the echo? Because I'm using the computer's mic.
The only place that I see that does not have a lot of issues, especially when we meet, nakwanga Google Meet, because everything inakwanga so smooth and clear, and kila mtu anaweza tu kujoin bila shida. I don't know what's wrong with Zoom. Yeah, because others are still not able to join. That is as per their comments kwa group. Which they got.
They are not able to join.
Yeah, first of all, three of them, like kina Collins wanasema, first of all, they're not able even to open the portal to see the link. So nimetuma link na bado hawajaweza kujoin. So
you see, if they cannot access the portal itself, it means they have these issues. Yeah, so that's the problem. And then the other thing about Google Meet is that you can't record. So I normally prefer this, because at least you are able to record. That's the issue.
Okay. Yeah. No, I think it's okay, because if you can be able to converse, then means I can understand you and I can reply. So
yeah, so if you're able to hear, apart from the echo, I think we are going to kind of ignore the echo for now. But if you're able to hear me clearly, then that's fine.
Yeah.
Okay then. So let me share a screen here. Okay. So we're going to tackle this topic, chapter 4, knowledge representation. And so I hope that you're able to see the screen that I've shared so that we can start.
Yes, I can see it.
Okay. All right. So just as I taught you about problem solving, we were able to look at search algorithms, how an agent can search for solutions in its search space. Just as we had that, now we need to see how, because for an agent to be able to solve problems in its environment, in its environment, it is supposed to have some knowledge in its knowledge base. Basically, knowledge is basically data. So there's a manner in which the knowledge can be induced into the agent, so that when it begins to be in operation, it can actually use that knowledge to solve problems. So that is basically what we want to discuss: how to represent or how to induce knowledge into an agent. So that being said, we need to define the term knowledge. Basically, knowledge is awareness or familiarity gained by experiences of facts, data, and situations. Knowledge is basically an awareness of things, an awareness of what is possible or what is. So it can be gained by experience, just the same way you can gain the experience of these units, AI units. So what I'm giving you is knowledge. I'm giving you an awareness. So it's a familiarity gained by experiences or some facts that have been gathered, or data or situations that an agent goes through. So knowledge is basically what is known. All right. Knowledge is basically what is known. Knowledge is it's basically what is known. So what is knowledge representation? Basically, knowledge representation is this refers to how we induce knowledge into an agent, how we give an agent knowledge, or how we give an agent data. So that is basically knowledge representation. How do we give an agent data? Yeah. So for instance, if you're for a human being, you gain knowledge by things like learning, like educationally. You gain knowledge by experience. There are some things you do not gain from learning in a class, you gain from experience. So there is knowledge by experience, and there is also knowledge by reading, which is academic knowledge. So basically, knowledge representation is how knowledge is passed into an agent so that now it can be put into use. That is basically what knowledge representation is. It is how knowledge is passed to an agent. All right. Therefore, we can actually, there are two terms that are normally used: knowledge representation, which is abbreviated with KR, and knowledge representation and reasoning, which is abbreviated KRR. Basically, this is an area that is concerned with how agents think and how thinking contributes to the intelligence of agents. So basically KR itself, it's the art or science of representing information about the real world, about known things to a computer system, so that from then on, the computer system can use that knowledge to solve problems and calculate algorithms and such kind of things. So KR is basically associated with how do we represent information about what we know about the real world, a particular area in the real world, into an agent, so that an agent can use that knowledge for problem solving. But when we talk about KRR, knowledge representation and reasoning, it is not just about inducing that knowledge into the agent. It is also about studying how that agent thinks and reasons, and what kind of solutions does it provide for different kind of problems during its operation. So basically KR is about inducing that knowledge, transferring knowledge about a real world to the computer system. Then KRR, knowledge representation and reasoning, it is about inducing knowledge into an agent and also studying how that agent uses that knowledge to solve problems. And KRR is normally a continuous process. KR can be once in a lifetime process where you give the agent data that it can use. You store it into its memory base. But KRR, while KR can be once in a lifetime activity, KRR can be an ongoing process because it is concerned with studying how the agent uses that knowledge over a period of time to come up with solutions. So KRR is basically what helps us to improve or to study the performance of an agent, and that is studied over time during the lifetime of an agent. Okay, so let's go back to KR and discuss what should we represent. And what we should represent is basically what we call types of knowledge. Okay, what to represent, what should we give, what kind of data should we give the agent. So types of knowledge can be divided into 5. There is declarative knowledge, heuristic knowledge, meta knowledge, rules or procedure, and structural knowledge. So we have declarative knowledge, heuristic, meta knowledge, procedural, and structural knowledge. Now let's discuss what declarative knowledge is. Declarative knowledge is these are facts about something, like concepts, facts about something. Declarative knowledge, for instance, if we are talking about a self-driving car and we want to give a self-driving car some kind of data that it can be used so that when it's driving, it can drive efficiently. Declarative knowledge is a concept. It's a fact that is unchanging over a period of time. For instance, we know that when a car hits another car, that's an accident. Okay, that's declarative knowledge. All right. We also know that it cannot speed. The self-driving car cannot speed at zebra crossing. We also know that the car cannot decelerate on a highway. It has to keep moving, and it can also not pick passengers on a highway. Those are types of declarative knowledge that does not change. Also, there are things about the road that don't change, things like road signs. There are road signs that don't, not there are, but really the road signs never change. The meaning of a road sign never changes. Okay, so when we talk about declarative knowledge, these are things, concepts that are unchanging. over time. Okay, so basically that is declarative knowledge, and it is basically concepts and facts. Okay, then there is what we call procedural knowledge. Procedural knowledge. Procedural knowledge is also called imperative knowledge, and basically it's a type of knowledge which is responsible for knowing the hows of doing something, and it's basically made up of rules, strategies, procedures, and agendas. Now, there are procedures of doing things. For instance, if we meet, let's say in declarative knowledge, we have a road sign. We have data about a road sign which tells the car to decelerate because there is an accident ahead. Now, we should also give that car procedural knowledge of how to maneuver through that declarative knowledge. A procedure, for instance, the first thing it has to do, it has to slow down and then, turn, not really turn, but, join the other lane. If this is the lane that has been blocked because there's an accident ahead, join the other lane. So basically, procedural knowledge is what guides the agent on performing activities based on declarative knowledge. Okay, that is what we call procedural knowledge. Another example is declarative knowledge, where we have something like on a highway, you can only accelerate and you cannot slow down or stop. So the procedural knowledge that will govern that kind of knowledge, which the agent can use, is basically, how do I accelerate? How do I overtake? Okay, so the procedures of doing all those things. Okay, so procedural knowledge is basically about the rules that govern how the agent performs things. In other words, to maximize on what we call the performance measure, even as we looked in the previous classes, to maximize on the performance measure. Because so just look at procedural knowledge as rules that govern the agent on how to perform different things. Okay, rules in order to maximize what performance measure. And then what is meta knowledge? Meta knowledge is knowledge about other types of knowledge. Okay, in other words, the agent should be aware of all these kinds of knowledge: declarative, procedural, heuristic, structural. And what that means is, by it having an awareness of all that knowledge that is in its memory, in its knowledge base, it is able to maximize on its performance measure even as it performs activity. So meta knowledge is the knowledge about knowledge. Okay, knowledge about knowledge is meta knowledge. And I think we should have discussed that the last one, but anyway. Then heuristic knowledge is a knowledge from some expert area. Is knowledge from an expert area. Now, for instance, if we are talking about a self-driving car, we may want, do you remember Turing test? Turing test is basically a test, a game that is used to determine whether a machine is as intelligent as a human. So in Turing test, you remember that we would use a human expert, and we may use a human expert and a machine, or we may use someone who is involved in that area and a machine. So for instance, if we are dealing with a diagnosis system, a robotic diagnosis system for a hospital, then we can take the human person to be a patient, all right, or just someone. But then we can also have a doctor, so that we can actually test whether it agrees, the kind of answers that it gives, it agrees with what the doctor knows, because the doctor is an expert. So when we are feeding knowledge into a system, we must represent knowledge that is expert oriented. So if it is a self-driving car, we must represent knowledge from the knowledge about driving. And that is knowledge that is with drivers, knowledge about driving. Okay, like how do you overtake, how do you accelerate, how do you decelerate, all those kind of things that a driver knows from an expert level. We have to represent that knowledge into the machine, and we normally use algorithms, mathematical calculations to represent those kinds of data. So heuristic knowledge is expert knowledge, and the benefit of heuristic knowledge is that it enables the agent to perform activities just as a professional in that area would perform. Okay, so that is what heuristic knowledge is about. Heuristic knowledge is knowledge from experts. Okay, then structural knowledge is a basic knowledge to problem solving. Now, structural knowledge is normally mathematical in nature. Okay, it's normally mathematical in nature, and when we say mathematical in nature, we are talking about things like algebra, probability, and statistics. These kinds of things that help us to know how to reach to a solution. Okay, by measuring relationships and probabilities and those kinds of things. Okay, like if X is greater than Y, what should I do? So structural knowledge is basically conditional statements that are tested mathematically. Okay, yeah, if a car is 10 meters in front or 10 meters ahead, what should I do if I want to overtake? Those if conditions, those are conditional statements that guide the agent on how to do things. They are called structural knowledge. Conditional statements. Okay, conditional statements. All right. So those are the types of knowledge. What is the relationship between knowledge and intelligence? Now, basically, knowledge makes someone or an agent knowledgeful, but the ability of using that knowledge to solve a problem is what we call intelligence. Now, what that means is we cannot have intelligence without knowledge, but it is possible to have knowledge without intelligence. It is possible to know things, but you are not able to interpret them or analyze them. You just have them. So knowledge is like a crammed kind of situation, all right? Like when you have crammed some notes and you are waiting for an exam. For some of you do that, and which is not very advisable, because it basically helps you probably to pass the exam, but you may not know much after that. You cannot apply. So basically that is knowledge, what you know. But intelligence is the ability to interpret that knowledge skillfully. You are able to discuss it. For instance, it is not enough for me as a teacher to just know my notes, but there must be an ability to explain what I know. All right. So my ability to explain what I know is what is called intelligence. Also, my ability to solve problems or to answer questions that are related to the knowledge that I'm giving you would also be considered intelligence. So intelligence is the ability to analyze and interpret knowledge and also use that knowledge to solve problems. Okay, so when we say that a machine is intelligent, we are basically giving a presumption that this machine is able to use this knowledge and to analyze that knowledge and interpret it and to make inferences or conclusions from that knowledge. And therefore, by doing that, it is able to solve real world problems. So that is basically what intelligence is. Intelligence is about analyzing the knowledge that you know. It's about making inferences or testing relationships and making inferences and conclusions, which can enable you to solve real world problems, all right, using that knowledge. Okay, so that is basically that's the relationship between knowledge and intelligence. Knowledge is an awareness about things, but intelligence is about making inferences and conclusions to solve real world problems using the data that you have or using the awareness that you have. Okay, so that is basically the relationship between knowledge and intelligence. Okay, so we can actually say that a machine is intelligent if it is able to solve problems using the knowledge that it has, okay, or if it is able to test relationships and make inferences or conclusions from the knowledge that it has. Okay, now let's look at knowledge representation life cycle. Knowledge representation life cycle. These are the stages that are to be passed or undertaken for us to pass knowledge to a machine up to the point where the machine can use that knowledge to solve real world problems. So the first step in the knowledge representation cycle is perception. The second step is learning. The third step is knowledge representation and reasoning. The fourth step is planning. And the fifth is execution. So basically that's where we have that diagram there to show the process or the stages that are undertaken to represent knowledge to a machine from the time the knowledge is represented to the machine to the time that machine can use that knowledge to solve a real world problem. So you have perception, you have learning, you have knowledge representation, and knowledge reasoning. They go together, and planning and execution. Okay, now let us look at each of them and how what each is about. So when we talk about perception, to perceive something is to sense or to detect. So when you talk about perception, is where we want to test if we want to test if an agent can actually perceive its environment. Okay, can it be able to perceive its environment? And that one we do by using the sensors, or what we call the sensors. And of course, if it's a self-driving car, we want to know if this self-driving car can know the marks of a road, the road marks that it is not supposed to pass, right? Like the lane marks. Okay, so we need to install some infrared sensors so that we can actually see if that car can be able to sense a barrier or a sign or a road sign, like a lane, which it is not supposed to pass. Okay, so perception is basically, can an agent perceive its environment? And then learning is about, can an agent gain new knowledge from what it perceives? Okay, because sometimes lane marks can be white, sometimes lane marks can be yellow. So is it able to know that a yellow mark and a white mark can be used for the same purpose, to divide a lane? in different situations.